Now that we know all the things that we could modulate, let's see what should we modulate. And by all means, this is not a rule. None of this is a rule. So everything that can be modulated should be modulated. And that's why it can be modulated. By flicking through various presets of synthesizers, you will actually see how the creators of the sounds got those sounds to be like that. But once you get familiar and know what each one of those modulator does, it's going to be easier for you to understand how they acquired and how they actually built up a certain sound. So you can analyze and reverse engineer presets that you get with the synthesizers to see how they actually got a certain sound. Now, to show you several examples, I'm going to start with Massive. I'm going to do a preset for you that actually contains no envelopes aside of the amplitude envelope that we must have in order to have the sound propagate from the oscillators. What I'm going to do is start with just using LFOs and, let's say, performers, just like this one. So let's say I want a performer that goes upwards like that. And then I can synchronize that to, let's say, 1/8. This is going to be a really long sound, like an FX riser, something like that. So let's try that out. I'm going to modulate the pitch of this oscillator. I'm going to lower the oscillator initially, like that, 2 octaves down. I'm going to modulate it 2 octaves up. So during this course of time, I'll let it go down 2. So this performer is just going to repeat these 2 in a loop if I let it. So I'm going to play the note and see what happens right now. Now, before I do that, this performer needs to have some amplitude. So I need it to actually work. I will play Massive. Okay, so let's play a note. Seems like my envelope for... Yep, seems like my envelope, the number 4 one, is actually the one that's assigned to my amplitude, wasn't playing at full strength all the time. Fix that, go back, let's see that. So we have that rise and then a fall. We can skip the fall and just go back down immediately, just to know when this is over. Or we can rise again. So just keep rising and then again rising. But I would like to introduce more change into this. So we have this oscillator. Let's make it a sawtooth completely. So a square and a sawtooth somewhere in between, or just a sawtooth. Let's make another performer that's going to do just this, which you see right here. Is going to do it, let's say, fast, like that. And I can modulate this pitch even further with another one of these. So let's do that. So we have the same thing going upwards. I just think it's too low. When it starts, the sound is too low. Let's start an octave higher. Maybe pull it down a bit. So now I have that change happening all the time. So what else could we do? So maybe we could filter that sound through a filter, let's say a high pass filter, and make it go downwards. So now I have this performer going up. I can make it push down on this cutoff. So move the parameter this way by engaging it a negative way, just like that. So it's going to start all the way up and go downwards. Now when I press the note, and it goes back down and starts again. So now we have a nice little riser. Now we can interchange that even more. Let's say we don't want this to happen at the end of the riser. So we could actually make this performer push that performer amplitude low. So do this. So now this performer applies its full strength at the beginning, but as the time progresses, the performer number 5 controls the amplitude of performer number 6. So this change is going to be really no more at the ending of this sound. So at the ending of this 8-bar progression right there. You see, this one totally dissipates. So the power of performer 6 is being reduced to nothing by performer 5. So we can actually make one of those affect the other one. Also, we could apply an LFO to this resonance. So a normal LFO, just like this, make it turn this resonance around. So what does that sound like? Okay, I like this change, so I'm going to make the performer number 5 affect the speed of the LFO 7. Also, interconnect those. That's good. Now I can deal with, let's say, voicing. I can do some unison voices and then make this go out of pitch. Quite crazy at the ending like that. Maybe even make it go more stereo. So this performer number 5 is controlling so many things inside of the preset. So I'm going to make it go really stereo at the end of the progression. I'm going to play it again. Like so. So there you have it. You can interconnect all of these LFOs, parameters, all of these modulators can be interconnected. And as you see on all of these modulators, we have boxes under each one of the parameters so that we could actually connect another modulator to that parameter. So even parameters of modulators can be modulated. Now, I don't know if this is a mind blow kind of information for you, but using this method and being able to modulate modulators allows you to make quite complex progressions and changes within your sound design. So you can actually create a sound like this that really progresses and changes, and I can make it change even more by applying this performer 5 to the oscillator, changing it from saw to square, maybe even change this oscillator to something else. And then by doing so, you can get a really crazy progression through time by just pressing one note, because all I'm doing when I'm playing this sound is I press one note and hold it, and that's it. So there you have it. This is the way we can make a really complex patch by using modulators to modulate parameters of other modulators. So interconnecting those to make really complex progressions. Now let's try to do something like that in Serum. Now in Serum, I'm going to initialize the preset. So I have everything clean, a clean slate. I'm going to start from the sawtooth once again. And let's say I wanted to do the same effect as I had there. I want this LFO to last for 8 bars like I had there. And I'm going to point that out to its CRS. That's the coarse pitch. So I'm going to be affecting that pitch, but not in a bidirectional mode. So each one of these LFOs, when affecting, a certain parameter, they can be bidirectional. So from the center point where the actual value of the parameter is at the moment, it can go halfway down and halfway up for this entire amplitude that it's going to be affecting. But I can make it unidirectional too. So in one direction from this parameter's current position and value. So I can make it go only up or only down or both ways. And the parameter's current value is going to be right there, exactly in the middle. So I'm going to make this value go unidirectionally, like this. So Alt Shift and click on the actual knob where I do the modulation amount. Now all of this can be done in the matrix. So you see whatever I routed right there is right here in this modulation matrix. So I have the LFO1 affecting A oscillator, so coarse pitch of the oscillator A in this amount. I can change the amount, how I want it to affect, and I make its type to be bidirectional or unidirectional. So if I change to bidirectional, go back, you see it's both ways. Go back to matrix, make it unidirectional, it goes only one way. So the matrix actually depicts every modulation you have inside the synthesizer. So let's try this out and see what it sounds like. I'm going to play Serum. Goes up quite a lot. I'll play a lower note or maybe... Yep, that's nice. So I'll make it trigger. So every time I press a note, it's going to start from the beginning so we can pick what's happening right there. And maybe I could even use a different waveform. So during the course of this change, I can make this wavetable change to like that. Nice. Now one thing, if I wanted to affect something out of LFO1 with the LFO2, I would have to go into the matrix and say that LFO2 is going to be affecting LFO1's rate. So I could do that too. Upwards. Just like that. Lots of crazy things that you can do using this interconnection between modulators, using the matrix or using just drag and drop methods of it. It doesn't really matter. What matters is that you can connect in your head what you want to modulate with what. So modulators are there to actually give you diversity in sound, to give you a time change in your sound during its propagation. So what you can do is modulate anything and everything that is available right here within the synth. So I could, by that method, I'm just going to turn this one off, the matrix, none. Okay, that can stay, doesn't matter, 0. Okay, so I could actually modulate anything, like a phase. Let's see what that sounds like. Modulate the detune maybe. And if I want it unidirectional, I just Alt Shift and click, and that's what happens. So now it's unidirectional this way, only upwards. The modulation less. Of course, that's depicted in the matrix. Nice, so you can do anything you want. One thing that we also have as an option is modulating things with the sidechain option, which would mean what? So let's try this. I'm going to modulate this filter with a really simple LFO shape. Like this, I'm going to make it bidirectional, like this. So bidirectional, and in this matrix, I'm going to say that the aux source is going to be the mod wheel. Yep. So the mod wheel is going to determine how much this LFO is going to be affecting this filter. So let's see, right now it should be doing nothing. Yeah, you see, I did route it, But since I have the mod wheel as an aux source, it's not doing anything until I bring up the mod wheel completely. So with the mod wheel at 0, this modulator is affecting this parameter, nothing. At maximum, the modulator is affecting the LFO as much as we said. So this is the maximum and the minimum is 0. So let's try that. This is also possible. I can actually make that aux source to be anything. I can make that aux source to be an LFO. So I can make the LFO2 be the aux source for that and make it really long so that as this LFO2's value is rising, this effect of LFO1 to the filter becomes greater as it progresses. So let's try that out. I have to trigger it, both of them. So let's try that from the beginning. So you see, when LFO2 is at 0, the LFO1 does not affect filter at all. And as LFO2 rises, that brings up the modulation amount that the LFO1 has on its actual parameter that is routed to, like this. All of these things you can, of course, do in massive, as I've shown you, so you can affect how much one parameter affects the other parameter. If I just go back to, let's say, a new sound, for each one of those, and let's say it's a filter again, I could, by any means, just do that. Let me just do serial. Okay, that goes in there. That's okay. So we have the sawtooth. I'm going to be playing the massive, thank you. Okay, so I will apply this LFO5 right there. Okay, nice. Now I have this sidechain option. So you see, while none of this is lit up, like I click right there, while I don't do that, all of these 3 boxes actually are used to modulate the cutoff so that I could maybe apply another modulation source to it. But if I click the sidechain, then I can use this last box as the sidechain value for this modulator 5. Now I can use, let's say, LFO6 as the sidechain value. Then I can choose right here if I want that sidechain value to affect it positively or negatively. Yep, just like that. So let's try that. I'm going to make this really slow so that we see how it actually affects the amount that LFO5 affects the cutoff filter. Just like that. Let's try that. As this sine wave goes up and down, the amount of LFO5 effect on the cutoff filter goes up and down, so it varies how much we affect it by just using a sidechain option. So that's also available in Massive too. So I've shown you before how to modulate filters, pitch, anything inside the synth that has a modulation box under it. Just like here, you can modulate it, and you probably should if you like the sound it creates when it changes. So what you could actually do is play something, move it with your hand, and if you like that, you can apply a modulator to do that for you. Now this can be a lot of fun, and it can take a lot of time and a lot of experimentation to get cool things, but as far as you go and experiment, you will learn more and more and more about how modulators actually affect things, and then in your head you might be able, after some training of course, to get a simple idea of what's going to happen once you interconnect and intermodulate some of these modulators that affect the parameters. Have fun practicing this.